Okay, welcome everybody. Welcome to this session on implementing DevOps, secure and compliant by default. So, if we could imagine the fact that DevOps gives us this promise that we can deliver more than 30 times a day and deploy all the time to production, but we can even be more secure and more compliant and more efficient than we have ever been before. The funny thing, though, is that if you look at the transformation that's ahead of us, is that if you look at organizations today, is that they more or less are built on this notion of a run organization where we have IT professionals, IT operations in there, data center operations that are running the business as is. And then we created this notion of a change organization that has developers in there, architects in there that build new software. And it's constantly this red wall in between where we throw stuff over the fence and then others need to take care of that. And with DevOps, what we're trying to do is we're trying to move away from this whole notion of having two separate silos for development and for running operations. And what we're doing is we're creating these value streams, these things that deliver value all the time, constantly. And what we're doing is we are moving this whole notion of change and run into one of these value streams. Meaning that every team becomes responsible for everything there is to do to not only build your product, but also run your product in production. That means that if you look at traditional ways of doing things like change management, incident management, capacity management, and all the other stuff that needs to be done to run an operation, we are now moving that towards these separate value streams where all these teams are responsible for delivering one of those pieces of value for the business. Now, if you start doing this, this means that there is no notion anymore of a dev team. There is no notion anymore of an operations team. And there's no notion anymore of a security operations team or SecOps. There's no central organization that will run your business. What we're going to do is we're going to create these autonomous teams that can do delivery themselves completely by themselves. So the only thing that we have left is DevOps teams. Those are the value streams. And every value stream is responsible for the compliance, the security, the cost that is incurred, how they do it, when they do it, and everything else, more or less. They are responsible for everything from idea to actually running it in production. And the idea is that every team is autonomous, meaning that no team should ever wait on some other team to get something done. You have all these capabilities within that value stream. That means that we need to learn a lot of stuff that we don't know yet, but we need to build that constant learning culture within our teams. Now, if you look at this and you look at the current state of how organizations are built and this whole new notion of DevOps, the first thing you might say is, this will be chaos, right? This must become chaos in my organization. Now, the cool thing is that there's been this notion of the state of DevOps reports. And what they've done is they surveyed all these organizations the past, 5 or 7 years. And what they came up with is that we can see that all these organizations that are moving towards DevOps are not all of a sudden in chaos. They start delivering their software in a much more efficient way, in a more secure way, and in a more compliant way, multiple times a day. Now the question is, how can we make this happen without creating chaos and delivering the right teams? So the conflict that we have to work with is that if you look at compliance, for example, then compliance in traditional organizations is, okay, you need to be compliant with all the rules that we have in our organization. Here's the handbook, 30, 40, 80 pages. And you go fill out those forms and then get stuff into production. And you need to hand that out to some compliance officer and then see if you meet the criteria. With DevOps, we try to deliver 30 times a day at least. We want to be on demand. Now, how can I fill in like a document of 30 pages every day? That's rather impossible. So what we need to do is we need to figure out a way on being secure and being compliant, but doing it in such a way that we can just deliver any moment of the day. Now the cool thing about DevOps is that in DevOps we try to automate everything we can. And by automating everything, we could then also incorporate the whole notion of compliance and incorporate the whole notion of being secure and delivering that in a totally automated fashion. And that is more or less the key to success, is by incorporating automation and adding all this notion of compliance and security towards your process of delivering, you can now do it faster and more secure. Now the question is, how do we do this? How do we make a practical approach on making this actually happen? Now the big question here is, if you look at the processes today in organizations, if it comes to security and compliance, what is the big lack that we have there? What are we lacking of if we look at those processes? Well, if you look at that, you can come up with the notion that consistency and evidence is always at a loss. We are constantly searching for how do we need to do it, and there's no consistent way of providing that. Now, the DevOps can bring some stuff to this whole notion, because DevOps is all about automating everything, is all about making it repeatable, and that gives us the consistency and the evidence while we're doing it. Now the big question is, what are the steps that we need to take to make that happen if you want to accomplish this? Now I boiled it down based on all the work that I've done with different companies, insurance companies, banks where I work for and help them with implementing DevOps, into more or less 3 simple steps to get to this whole notion of secure and compliant by default. First of all, we always need to go back to the basics, and I will come back to that a little bit later. Back to the basics is a very important part, because if we start working with these big documents that we need to comply with, then we are at a loss. The other thing that we need to do is we need to constantly and rigorously shift left. And with shift left, what we mean is that we put things into the development process, into our team, and we're not putting anything outside our team, and that we do not become dependent on somebody else. Remember, if we create autonomous teams, they need to operate autonomously, so we need to do it ourselves in a smart way. And the other thing that is really crucial here is that everything we do will be in code. Now that is a big thing if you look at how a run organization is run today. That's a big thing if you look at all the documents. How can we change these documents into code in order to be compliant and secure? Now, if we go back to the basics, then the fundamental question that you have to ask yourself all the time is, do old constraints still apply? And that's the reason I put these rockets from SpaceX on there, because they are changing the game if it comes to how you build rockets and how you go into space. What we probably all see if you look at, for example, Ignite and all the sessions that you've seen here, is that our industry is changing rapidly. And one of the big changes that we see in our industry is that the constraints that we live with for all those decades are moving away. They're changing. And we're moving to the notion of software-defined compute, software-defined infrastructure, software-defined anything. So we can define more or less everything in software these days, although what we see is that our processes and the way we build our organizations are still optimized on the whole notion that that's not possible. And we have physical things that we need to make happen. So the rules have been changed, and we need to adapt to those new rules to make this all successful. That means rethinking the way we're doing stuff. Now, if you look at, for example, risk management in organizations is also this whole organizational part. And remember, these organizations have been built around these silos where they are incentivized, for example, to be doing the right risk management in their organization. They have a whole business unit being responsible for that. Now, if we boil things down and look at the software development process and the change that we are going to create all the time in production, then risk management, if it comes to software development, more or less boils down to this notion of a 4 eyes, a 6 eyes, or an 8 eyes principle, where we have these more or less gates in between, where we always have at least one additional person that is present if we want to release some software. Now, the cool thing about this whole notion is that we can incorporate this already in our software development process. Because in our software development process, we can, for example, make use of the notion of a Git repository where we store our code, and then we have this notion of, let's say, a pull request, and we always say, well, we only accept pull requests before we can get something into in our code base. Now, that way, I always have a handoff to somebody else in the team that needs to review something, hence giving me a risk management measure that we can use. Now, if you look at the basics of compliance and we boil that down to its essence, then if you look at all these compliance frameworks, and I've worked with many risk managers and compliance officers and change managers in the past few years, if we boil down to SOX compliance, if we boil down what it actually means to have an ISO certification, it in 99% of the cases comes down to traceability. If we do have good traceability of a change that we want to create, and we can follow that along the whole process, then all of a sudden, if I can provide the evidence, we can then have the traceability within that whole process. If you look at the security basics, then what we can do is we can create some simple rules to actually make things go to production in a safe and secure way. And one of the things that a simple rule that you can use, and if you're, for example, deploying to Azure, so you say, well, if you look at the production subscription where we push stuff into production, there's only one way, and one way only to get something into production, and that is through automation. So instead of having somebody have a Word document where to click in the portal to get something into production, now what we're going to do is we kind of automate that. We push that into software in code. We check it into our source control repositories, have our pull requests to validate if somebody is doing the right thing. And the only way we can then move that to production is through the deployment pipeline, as we call them, and software defined. So it's a very simple rule to make this happen, and it's not that complicated to implement either. But the other thing that we need to do is we need to shift left. I mean, just by defining something in software does not make it inherently secure. We need to look at our value stream and what is it that we are exposing to the outside world. We need to incorporate techniques in our development methods on how we assess the risk that we have by, for example, adopting the secure development lifecycle process that Microsoft, for example, has published online that we can follow along. And what we need to do is we need to then make sure that everything we do in our development environment is constantly validated against those rules and the things that we want to do in production so that we can learn very early on what is going on and how we should mitigate those things. Now the fun thing is that if we have these very small value streams and we deliver many times a day, then every change that we create is very small in essence. And every small change does not require a whole big environment to test if it comes to security policies that you might have in place. Now, one of the other things that we do a lot is that we say, well, all environments that we create need to be the same. That means that our development environment is exactly the same as our test environment, is exactly the same as our production environment. And what we're going to do is we're going to create the deployment pipelines that make this happen. So the moment I commit my code to our source control repository, we have some automated process that makes some production artifacts out of that. We push that in through our deployment pipeline, and all of a sudden that comes into, let's say, our development subscription in Azure to validate if that's actually working. And then what we can do is say, okay, this was okay, we now automatically improve that, and we go to the test environment where we do exactly the same, only we switch the credentials out. Now, we can map, for example, in Azure, the credentials from dev, test, and then production by using things like Key Vault and the integration we have with various products to make that happen. Now, the other thing that is fundamentally different if we want to do this on a daily basis is that instead of thinking that we're safe, we always need to assume that we are at breach. That means that we go and figure out what would be the worst thing that can happen if we are breached at that moment? And can we detect that it's actually happening, yes or not? So what we're doing is during our development cycle is we're trying to do anything we can to avoid that we are being breached by all kinds of practices like the secure software development lifecycle, and by, for example, incorporating all kinds of tools that can scan your software and can validate if you're using secure packages and if you're not exposed to known vulnerabilities in software. But the other thing that we need to do is we need to explore new ways of knowing that we are under this breach situation. So for example, one of the things that you could do is that you have in your team this notion of a red team and a blue team, where the red team is then constantly trying to hack your own services. And if they found a way, then you can mitigate that and adapt that in your learning cycle all the time to improve your security practices on a daily basis. So what you do is you create this red team, and then we have a blue team that is then there to eventually fix the things that are being breached by those teams. And this is one of the things that, for example, has been done within Microsoft to ensure that they provide the services they have on Azure, on Office 365, etc., to say that we're constantly validating our own security practices and make sure that we're constantly improving and learning new things. Now let me have a look at a practical implementation using, for example, Azure Cloud and Azure DevOps. Because there's a pretty easy way of setting this up. It's not rocket science, but you just need to have seen it once, and based on that, you can take it forward for your own organization. Now remember that there's one crucial piece of this puzzle, and that is nothing gets to production without a production pipeline. Meaning that everything needs to go through the deployment pipeline to ensure that we have this notion of traceability and that we have this notion of a 4 eyes or a 6 eyes or an 8 eyes principles, depending on the risks that you are taking if it comes to that piece of software. Now, if you look at your Azure subscription and how you should set that up, is that you should set up this notion of a subscription where we have all our shared resources. For example, ExpressRoute would be one of those resources that you would put in that particular subscription. And this subscription is managed by a team which has one value stream, and that value stream is to provide automation services to other teams. You are not dependent on that team. The platform team is not something we're dependent on, but they are the ones that create these resources in the shared environment. Now, they also need to use a pipeline to get stuff there. So they also will have this notion of a dev environment and a production environment, and they push every change to the infrastructure by using, for example, Azure DevOps. Now, if we then create subscriptions per value stream, that's the way we can ensure that every value stream has this notion of a dev test environment and a production and acceptance test environment. And you see that I created these two colors in there. If you look at what you can do with Azure Policy Management, for example, we can create these policy sets where we can say, well, we create this notion of a policy where everybody can do more or less everything in their development environment, but we have restricted policies, more restricted policies in acceptance and production. Now, the way this works is that our development teams then also create new software and deliver any change they do to those subscriptions by using these pipelines. And once we have this in place, we have a very easy way to validate constantly what we are delivering. We have traceability in place, and we have the 4 and 6 eyes principle in place if needed, so we can very easily then move faster to production on a daily basis. Now, if you look at your configuration for Azure DevOps, for example, one of the things that you should do is you always should create this notion of a branch policy. The branch policy will prohibit you from checking into something to master. And what we then always need to do is create this notion of a branch where we make the changes, create a pull request, and that pull request is then validated by somebody else in your team, getting you the 4 eyes principle in place, and making it very easy to move then to production. Now, be very aware of this, this check mark here. If you allow users to approve their own changes, then you're lost again, because that means that you do not enforce the 4 eyes principle in that pipeline, okay? So it's a very easy check mark, but it will be rather devastating if it comes to compliance. Now, if you look at the setup of your pipelines, what you can do is you can set up this notion of these approval points, so that can be pre-approval or post-approval, depending on what you need to do. And you can make these approvals by some physical person, or you can make it by something which is called the release gate, and that can be done on telemetry. So what you see is that at first, when we start doing DevOps in organizations, we start with this notion of somebody that needs to review the changes all the time, but eventually they will get very, very fed up with the fact that they need to push a button 30 times a day. Okay, and after the fact, they start asking us, can we not automate that? And that's the moment I kick in the release gate, okay? So don't start by the automated release gate, because we build the trust in the organization that we're doing it right. And after that, we can then just move to the fully automated state. But that's one of the things with DevOps. We need to empower people. We need to make it possible for the whole team to deliver all the time. And we need to build that trust within the organization. Now, what I would like to do as the final part of this session is show you something about this traceability and how that looks like if you're using Azure and Azure DevOps. So what I have here is I have a couple of demos that are not showing. There it is. So what I've done is I have here, for example, a Kanban board, and on this board what I've done is I put this one into closed, and I've ran to the set of stages that I normally need to go to actually deliver something to production. And what I deliver to production is that I have this home page, and I make this change to the home page that we're now secure and compliant by default. Very simple. Now what you see is that if I would follow this card along, then because of the policy that I set within Azure DevOps, I can then look at my card and I can exactly see what happened during the development process. You can completely track that. So you can see that all of a sudden all the related work that is there. And if the network is helping me a little bit, then it should be able to see all the points that it has gone through. There we are. Okay, so you see here that, for example, there has been a change that's been done in the Git repository. We have a pull request there, and that is then eventually being pushed into this delivery pipeline, where we have, this is the repository, where we also have all the infrastructure as code available within that Git repository. So any change to my infrastructure would go into code, and that would be pushed into the Azure infrastructure. And then we see here that I have this build, and this build has picked up that change within the Git repository. I can then follow that along, and this build is then eventually pushed into this continuous delivery pipeline, and this is where we then have the stages where we go through to move that to production. Now I can follow along and I can see, okay, if I look at this release, what is actually in there, I can then completely track that back. If I go here, I can completely track that back. What are the steps that we've been taking? And we can exactly see, for example, who did actually approve the step that we've gone through. So I have this traceability points within this complete release pipeline, giving me all the benefits of at least being compliant with all the rules that we have in the organization. So to sum this thing up, how to be secure and compliant by default. Key thing is automate everything. Automation is your friend, and by automating everything, that means that we are able to track our changes throughout the full life cycle of our product. We use version control for everything. I prefer to use Git because it has pull requests built in there and it's pretty easy to use. And we always need to use pipelines for everything. There's no way you can get to production without having a delivery pipeline. The implications of this is that we're going to use configuration as code, infrastructure as code, security as code, and everything is done through that version control repository, pushed through the deployment pipeline. And with this, I want to thank you so much for your time. I hope you enjoyed it, hope you learned something. My name is Marcel de Vries. I'm the CTO of Xspirit, company in the Netherlands, and thank you for listening. Oh, and please fill out the evals. That always helps. Yeah, just at least to know what you think of the session. And